So please check those out. Let's try to be efficient with our time. I think we should be able to get to a good place before we're done. I just want to continue to encourage you all to work together, compare answers, question each other. It's about you learning, so let's communicate. To these, and we'll see if there's anything worth talking about. I don't know if I need to do any zooming in here, but is that large enough to see what you need to see? You can zoom if you want, but so for A, we find out that g of x is continuous at negative 1/2, and notice that I tried to use really nice, rigorous notation. Rigorous just means precisely said or precisely written. And then you found out that since negative 25 indeed does not equal 25, then at that other point, x equals 5, we have a point of discontinuity. Can anybody describe what kind of discontinuity we have at 5? It's a jump. Yeah, whenever you've got different behaviors from left and right, like one of these guys, we call it. It's not worth throwing things as well. Okay. Letter A there. B. There's some tricky stuff with B on intervals and domains that you had to make sure you got things lined up correctly. It turns out that the IVT does apply because on that interval, at least, g of x is continuous. And then you're able to find a value above and below. You could use the IVT to prove that, indeed, at least one time, g of x equals negative 7 on that interval. I heard a wait.
Why did you use g of 5? Or is that g of 3? It's g of 3. Never mind. Add g of 3.
I don't know. Maybe I need to change.
Is that g of 5 or g of 3?
It kind of looks like a 5. Maybe I should change that. That's a 5. Maybe I should use a 4. Yeah.
Because g of 4.
I went out of my domain. Yeah. So let's change that. There aren't very many typos in these, but if there's a typo, let's fix it. So instead of g of 5, we could do g of 4, couldn't we?
No, g of 4 doesn't.
G of 4 doesn't give us what we want, but g of 3 does?
Yeah.
Okay, fair enough. So g of 3...
G of 4. Why can't you use G of 4?
Well, g of 4 works fine.
16 times.
That'd give me negative 21.
I'm dumb.
Well,
I did 16 times 3 minus 50.
I was outside my own domain, so let's take it easier on yourself. So g of 3 would be
G of 4.
negative 17. The g of 4 would work too. There we go. If we make those two little changes, we're in good shape. So yeah, thanks for asking. And sometimes my 3s might look like 5s, so also worth asking.
What I did when I saw that problem is I essentially, it's not continuous on that problem, and then I set it up because the equation top is negative 4x minus 5, and I set that to negative 4x minus 5 equals negative 7, and then I solve for that point, and I set it up as x of 0.5 equals.
So you basically found exactly where it happens. Yeah, and so I didn't give like great instruction on what method I would want you to use, right? So it didn't say, it didn't say for what x value does g of x equal negative 7, right, which you kind of answered, but in a roundabout sort of way, like if you came back and said, well, sure, g of x does equal negative 7 because I found it right there. That's essentially your argument. And I'd say based on the way this question is worded, I don't know, I'd say that's fine. I was really wanting you to use the IVT because I can for sure tell you that, future efforts, I might even come right out and say, use the IVT to show. And so in a case like that, you'd have to do some kind of argumentation like this. But yeah, I would say based on the way that I worded it, I didn't say that you couldn't do that. And so the fact that you actually found the value is fairly good proof that yes, it does. Yeah, does it make sense? That
does make sense.
Okay. Your way is certainly logical, and I didn't write that possibility out of the question, so it's good. Good math is good math, always. Yes, sir?
Is the 3 dots, like in the triangle, is that something we have to do to answer the question? Or like...
No, you could write the word therefore.
Okay.
or you could write the word so,
Okay. So
or
what does it mean?
it means therefore.
Okay.
Yeah, so yeah, little dotted triangle means therefore. And we'll use that a ton. I will say you'll probably start using it because it will become the best way to do it
Okay.
as we do other things. So, yeah. Great questions, thoughts? What else? Anything? Jed?
So for number 2,
Yep.
what would the difference between like factoring it out and graphically? What would the difference be? Because you're canceling out a -2 and the x.
When you say what would be the difference
like
in regard to showing your work or in regards to
No,
an answer?
I'm just curious, like if you were to graph the original equation and
Oh,
the
gotcha,
factored
'cause-
equation.
Because when you do the canceling, it indicates the removable,
Yeah,
but then there's still a vertical asymptote there, right?
yeah,
I would just say that, like graphically, there's going to be a vertical asymptote for sure, and the two, it still maintains the integrity of there being a gap, right? But I would say that I guess I'd put it this way: if you have a vertical asymptote and a removable discontinuity at the same place, like in this case, the vertical asymptote trumps the removable.
okay,
It takes the thing that used to be removable and now it's not removable. So it's like it's the stronger of the two, I guess,
okay,
graphically speaking. Does that make sense?
Yeah.
Am I answering your question?
yeah, I think so.
Sometimes people ask a question and I have this great answer and they're like, that's not really the question I asked. I'm like, well, it sounded good to me. So if I'm misaddressing your question, certainly let me know.
Yeah.
Okay. Great thoughts, questions. What else can I do to help with any of those? Okay. Fair enough. So we haven't done this very much. Maybe we just did this once. We're going to go back in time a little bit. We are going to go back to the one question we didn't quite get to last time, and it's right. I missed it. All right, number 2. This one right here. It is right there. Perfect. Okay, so last time we finished by finding the equation of a tangent line. We did all kinds of things with derivatives. And I've given you some hints about this one already. And I'm going to have you guys give some input on what you think we ought to do. It says selected values of f of x are given in the table below. Use the data in the table to estimate. Again, we see that word, f prime of 10. So before we go too far, I want to hear from you guys. Are y'all okay with this symbology right there? Do you know what that means? Anybody verbally express when you see find f prime of 10? What does that mean? Derivative of f at 10. Yeah. So you could say derivative of f at x equals 10. I think that's a nice interpretation. Can anybody think of another interpretation that is just as good as that one but describes things a little bit differently? Okay, let's talk about that. So you could, and here would be the symbols. So I think I know what you're getting at. This would be how you would write it if you wanted to use those Leibniz variables. You'd write dy dx at x equals 10. Okay. That vertical line usually means evaluated at, or evaluated from this to that, or something like that. It means evaluated. And we'd say evaluated x equals 10. That would be an alternative way to write it, and that'd be fine. But what about explaining like what it actually means? You know, what Hunter said is fine. I think it's great. But could you do it differently? Another way of describing it. What do you think, Carter? Inverse? Not inverse. We actually will talk about inverses in the not too far off future. But I would say we're not talking about inverses here. We are talking about a derivative idea. Graphically speaking, what does the derivative mean? Slope. Okay, so this is good. What Hunter said, totally fine. What if I started off by saying it's the slope of ... How would you finish that? Go ahead. I interrupted, I'm sorry.
Wait, we said,
Oh, you said, oh,
the
sorry.
slope of f of x evaluate. It depends if it's linear or not. The slope of f of x.
It really doesn't depend on if it's linear or not. Slope of f of x.
X equals 10.
Sure, that's another way of doing it. You guys okay with these translations? There's one more, and I will start it off the same way. I'll say it could be the slope of what? The tangent line. There you go. That's another way of saying this. Slope of the tangent line at x equals 10. All of these are accurate. They all could apply depending on the situation we're trying to apply them in. So, can anybody see any issues here? Maybe see some ways to, you think we could handle this? Like what could I do? Luke, what do you see?
You can find the slope like from 8 to 11 on the graph.
8 to 11?
10's in that range.
Okay. What do y'all think about that? He said find the average slope between 8 and 11. Any other thoughts? What about 8 to 12? Would that be okay too? Probably not as accurate. It's kind of hard to say,
Yeah.
right? Why would you choose 8 to 11 instead of 8 to 12?
It's a closer interval.
It's the tighter interval.
Given less space until 10.
Yeah, the closer you get, the better. Yeah. So I think I like that. I do. And I want to bring up a point with this for sure. So let's go ahead and do that. Let's take Luke's idea. He said find the average slope. So I would say something like this. F prime of 10 is approximately equal to, what would be the numbers I'd use to approximate this? Like what would be the numbers in the numerator of my approximation? 1 minus 0 over 11 minus 8, right? It's change in y divided by change in x. So this ends up giving me 1/3. That'd be my approximate value for f prime of 10. I would say this one is a little bit, this one is totally fine, and I think your guys' idea is great. I think it's perfect. But I will say, as far as like AP tests and things like that, the standard practice is the number, like in this case the 10, the number we're trying to approximate at is always going to be exactly in the middle of two of the data points. So if this was an AP question, instead of 8 and 11, it would probably be 9 and 11 on the x's. Does that make sense? Because 9 and 11 are equally spaced around 10. So I would look for that kind of spacing when you see a question like this where you're trying to approximate a derivative.
Don't use 8 and 12.
So 8 and 12, so 10's right in the middle. And so like on a testing scenario, I'm going to make it really clear. Like if I want you to do 10, I'm going to give you 9 and 11. If I want you to use 6, I'm going to give you 5 and 7. I'm going to make it as obvious as I can. This one is maybe a little bit in a gray area. I wanted to do that just to get you to think and have this conversation. But keep it tight, and then that number should be right in the middle of two data points. Okay, so there's that phrase I think I shared with you guys sometime before. Here it is. If you can't differentiate, did I tell you this before? If you can't differentiate, that's fine. Just use what? It rhymes, so that's helpful. If you can't differentiate, that's fine. Just use, what did we use? Time? It almost rhymes. Something with line.
Tangent line.
Not tangent line? Yes. So you just use the slope of the secant line. And that's what we did. We used the slope of the secant line to help us approximate the value, the numerical value of a derivative. And that's the best we can do based on the information we have. All right, you guys doing okay with derivatives and stuff? Okay, so let's review really quick while I do some adjusting and erasings and such. The derivative is, there's three ways to say this. The derivative is the slope of the tangent line. The derivative is the instantaneous rate of change. Or you can say the derivative is the slope of a curve at one point. So those are kind of the three ways we put it, and we'll pretty much use all three of those. But we're going to focus on tangent line stuff here today. And so the question becomes this. Yeah, that's basically it. In certain situations, the tangent line will be able to be found. Like you'll be able to find it. You can actually calculate it, but there are going to be certain situations where no, you can't. And we're going to focus on those no, you can't situations today. And so let's talk about some terminology briefly, and then we'll get into some details. We're going to do a lot of guided stuff today. You'll do a little bit of this on your own, but we'll do a lot of guided stuff. So in certain situations, you're simply not going to be able to find the derivative, not because you lack the skill, but simply the derivative won't exist. Okay? So differentiability is talking about that, speaking to that. So for a function to be differentiable at a point, the graph of the function must be continuous and the derivative from the left must equal the derivative from the right. This is not an exhaustive definition. This is just kind of a nice description. So function has to be continuous, and the derivative from the left must equal the derivative from the right in order for a graph to be differentiable. So if you look at these first two, why would there be a bunch of points of non-differentiability on that graph on the left? Say again? Not continuous. You can see this is the classic step function, right? The greatest integer function. So this is not continuous at multiple points. And so at each of those points where that graph is not continuous, those are all going to be points of non-differentiability as well. Okay? The one on the right, can you see how the one on the right is continuous, at least for the graph we can see? Very continuous. Can anybody guess as to where and maybe why there's a point of non-differentiability on that one?
All values except for
Y equals 0, aka x equals 2. Yeah, so right here, that is a point of non-differentiability. And let's talk about why. You can see it kind of spelled out. Do you see how from the left, the slope of that graph is -1? And then from the right, the slope is +1. And that change from a slope of -1 to a slope of +1 happens in a single instant, right there at x equals 2. So we will often refer to this as a sharp point. This is not a great, rigorous way of putting it. It's a nice description. It's a sharp point. It's not a smooth turn, like a parabola or something like that. So if you've got the sharp point, that's going to be a point of non-differentiability. We're going to be a little more rigorous in the way that we describe this. I get a grade AP tests every June, and there's all kinds of crazy ways people describe these things. And so we're going to try to be as rigorous as we can to make it clear. Sharp point is like fairly clear, but we're going to use some good math as well. There's a long list of like words that are not allowed to be used for these. I'm not going to tell you them all. I'll just maybe share one with you at some point. But anyways, let's call these sharp points for now. Fair enough? We'll do some math with it in a second. But there's one more. I'm really hoping that the continuity thing came together here for you. So I'm thinking if we wanted to show that this is a continuous graph at x equals -3, I would write something like the limit as x approaches -3 of h of x, and we're approaching, say, from the left, equals the limit as x approaches -3 from the right of h of x. And they both equal h of -3, don't they? And what's the actual y value for that x value? 1. So if you said that all three of those things, they all equal 1, haven't we shown in a fairly rigorous way, and really minimalistic as far as the amount of junk you got to write? You don't have to write a bunch of sentences. You just write this one statement, and we showed that all three of those things equal 1. You'd have to say that this is a continuous graph at x equals -3. Did anybody try the differentiable thing and feel okay about that? There's a doink point. Yeah, let's not say doink point. I got to say, I won't give you credit for that, but you get a laugh out of me for sure. But okay, so see if you agree with this. I would say, now that we've established continuity, we could say the limit as x approaches -3 from the left of h prime. Remember, in order to be differentiable, we want the derivative from the left and the derivative from the right to be the same.
There it is.
So from the left, I would say that we can actually figure that slope out. And I would say that that slope is 1/3. Okay, so from the left, I'd say h prime is 1/3. And I would say that that does not equal the limit as x approaches negative 3 from the right of h prime. And I don't know that I could get real specific like I did with the 1/3, but what could I say? It's negative. I can for sure say that. So I would just say, I know that those two things are not equal because one of them is 1/3 and the other one's negative, which pretty much guarantees that they're not equal, right? And so because of that, I would say this proves that h is not differentiable because from the left and the right, h prime not equal. One's 1/3, the other one is negative. What do you think? I think that's about the best we could do because we don't know exactly the numerical values on the right side.
Can you just write that there's a sharp point at x equals -3?
So this kind of precludes that. Sorry. This precludes that using rigorous notation. I say sharp point is a nice description. You know, like if I said, how tall is Mr. Hovis? And you said, really tall. That's a pretty good description. But if somebody said he is 6 foot, 8 inches, 8.134 inches, that's rigorous, right?
Yeah.
So I want you to go down to like the 1,000th of an inch, so to speak, right? I want you to give me a good mathematical statement on why that is. If I didn't say use like quality, rigorous notation, then if you said, hey, there's a sharp point there, I think it's a good description. So we want to go beyond just good description on this one. Any other thoughts or questions there? Okay. We're going to do one more. But while I have what I feel like is probably your full attention, I just want to remind you that you can do quiz retakes on quiz 1. Tomorrow during the connection time would be a prime time to do that. We do have our quiz on continuity in the IVT on Monday, and so I feel like things can snowball on you. So, there's no pressure. You don't have to do your retry by tomorrow, but the sooner you do it, the less of a snowball it's going to feel like. Because then if you feel like you need to do a retry on that one, and you're like, oh my gosh, I got 2 of them, right? Less comfortable than it would be to just do 1 at a time. So please consider. No one's forcing you to do that at this point, but just food for thought. Okay, so let's do our final question of the day, and it's right here. It's number 1. Does the general phrasing of this sort of sound familiar? Haven't we done ones like this where it wants to know continuity? Find the values of constants A and B so that such and such is continuous. We've done at least like 2 or 3 of those, right? So this is similar, except it says, what is the value of k plus c if f of x is differentiable? And what does differentiability imply? Continuous, yeah, continuity. So we want to know the values of k and c if f of x is differentiable, and by implication, also continuous. That's an implied relationship. And notice I've given you the piecewise rules for f and f prime. There will come a day in the near future where I would just give you f on a question like this, and you'd have to figure out f prime on your own. So what I want you guys to do is realize that because the continuity is implied here, will you guys please work with continuity? This would be another good opportunity to practice really for your quiz on Monday. Can you take that f of x and can you write a nice rigorous notation step to establish continuity? Give it a try. I will quietly write it up here. We'll see if we agree on that part. So I've just written kind of the initial statement up there if you want to check. Unless I've made some copy error or something, I think I've got it good up there and certainly bless you. easy way to win hide and go seek with Joe. Just make sure, get him to sneeze once or twice, and you will find that guy. All right, so I hope that statement makes sense to you. I would then go through and, like we've done before, I would actually try to evaluate these, right? So I would try to evaluate the first one, and if I did, I'd get 27 plus 3c, and that would equal 18k minus 3. And then the f of 3 is actually contained within the cubic, so I don't have to write that again, unless I feel like getting bonus points, which you don't actually ever get. So whatever, I would just stop right there. I'd love to solve that equation. Why can't I? 2 variables. So what am I going to need? Another equation. Where do you think I'm going to get that other equation from? The differentiability stuff, right? The other one, right? So I'm going to come over here and say I have established continuity with the stuff I did on the left, but now I need to establish differentiability. So I'm going to write the limit as x approaches 3 from the left of 3x squared plus c. Those of you that know the power rule can maybe see that power rule in action here. We'll get to that in the near future. Equals the limit as x approaches 3 from the right of the other piece, 4kx minus 1. And just like before, we're going to try to evaluate these two limits. So I'd get 27 plus c equals 12k minus 1. And so as you all mentioned, we got 2 unknowns. We need 2 equations. We have them. What is our methodology going to be as far as solving something like this? Yeah, okay, substitution, plugging in, same idea, right? So we'd substitute by plugging in an expression for either c or k, depending on which route you want to go. I would say it'd be easiest to solve for c on the equation on the right. All you got to do is subtract the 27 over, do your substitution. I'll let you guys wrap that one up. I think I might remember the answer. Let's see. Anna, you're giving me that look. Did I say something wrong?
No.
Okay. Sorry. I'm still trying to learn your all's looks. Are you good?
Yeah.
Okay. I did what I tell all my Algebra 1 students to do. I tried to do this in my head, and I already mixed up which one is which. One of them I think is 8, and the other one is 3. Am I doing that right? Gavin says yes. Everybody else is like, I don't know. At least me and Gavin are together on the whole 8 and 3.
That's not my name.
Well, I could be wrong. Like I said,
I think you're right. Yes.
Okay, well, at least there's 2 of us. Okay, so yeah, you're supposed to find the k plus the c. I think this is an old multiple choice question from an AP test. So they just wanted like a single number to grade on that. So
That's a multiple choice question.
yeah,
How many of those are there?
this would be on the tougher end as far as time goes.
Okay.
There'd be like this one. I would say I'd budget like 5 minutes for this one. There would be others that would maybe take you 20 seconds. The average, with the no calculator part, the average is 2 minutes per. With calculator is 3. People are never pushed on the 3 minutes per. The 2 minutes is a stretch. It's hard.
For like if this was a multiple choice, would you advise writing out the limits? Or
No.
just, like save time? Just-
I would, yeah, with multiple choice, since you're not graded on quality work there, I just write whatever you got to write, get her done. If it's open response, free response, then yeah. So, yeah, for sure. Figure out where you can cut some time. And as the test gets a little bit closer, we'll talk a little bit more about some hints and tricks about how to be fast. Let's see here. So that's 81. That's 108. 18K.
Is there a website every day? Is it? So
No.
Yeah, we don't have one.
Mr. Anderson?
Anyways, Guys, great job. I need to, is it 8 and 3 for sure?
Yes.
I did it in my head and it made sense. Now I'm writing it out and I'm like, wait a minute, I think I messed something up. So I'll wrap it up. Don't worry about it.
There you go.
That's what we did right here. We basically said we're going to force this thing to be differentiable and we're going to make the K and C be what they need to be to make that true.
I can't
Yeah.
believe where I failed here was on my.
Okay, so what did I do here? C equals 12K.
I did it all before.
Oh, wait a minute.
And then I just failed it all on my algebra.
26. So then, there we go. 26. No, it's 20. It's minus 28. Yep. Sorry, I'm just making all this work for my video. 28.
It's 3 and 8.
28. So that's 60. So that's 84. Thank you. See you later.
No.
So you add 84. That's 81. Oh, you subtract 27. That's it. There you go. 54. K is 3. Therefore, C is 8. Goodness, Cole. I did it better in my head than I did it when I wrote it. How about that?
That's weird.
No good. No good.
I'm just glad I did it.
So therefore, K plus C is 11.
I'm not
Carter,
happy-
appreciate your hard work, man. Thanks for your
I'm not happy
contributions.
I got it right. I'm happy I didn't get it wrong.